4.2. Collecting like terms. Don't forget the date, and don't forget your name, Tara! Terms that can be represented by algebra tiles with the same size and same shape are called like terms. Negative 2x squared and 4.5x squared are both like terms because each can be modeled with x squared tiles. So when we look at our algebra tiles, we have our x squared that looks like a big square. The big square, not the small square. Each term has the same variable, x, and it is raised to the power of 2. Another example of unlike terms would be negative 2x squared and 7x. Each term would be modeled by a different algebra tile. So this one would be modeled by 2x squareds, and 7x would be modeled by 7 long skinny rectangles. 1, 2, 3, 4, 5, 6, 7. But the key here is that these are long skinny rectangles and these are squares. If you are moving quickly to the symbolic kind of representation, we're saying that the x here is raised to the power of 2, whereas the x here is raised to the power of 1. Not 0, but 1. Each term is modeled with a different algebra tile, and each term has the variable x, that is true, but the exponents are different. So, example number 1. Simplify the polynomial 4k squared minus 1 minus 3k minus 3 plus 5k minus 2k squared by combining like terms. So let's start off with method 1. We have algebra tiles. So here I would draw 4k squareds. Oh, I shouldn't use x squareds. K squareds. Minus 1, which is just a little box here. Minus 3k. Minus 3. Plus 5k. And I'm just going to move over here. Minus 2k squared. So what I'm going to do is I'm going to do the adding and subtracting just on the same colored shape, the same size shapes. So I have 4k squareds here, but what I'm going to do is I can't forget the sign that comes before it. And I am going to subtract 2k. So what is left over here is I have 2k squared next. We're going to deal with the k's. So we have our long rectangles. We have negative 3k plus 5k. That ends up being plus 2k. And then let's deal with our ones. We have negative 1 minus 3. Don't forget the sign in front of it. So what I'm going to be left with here is negative 4. So just to write this out here, we have 2k squared plus 2k minus 4. Let's try method 2, symbolic. So just to rewrite the question here, I'm going to say 4k squared minus 1 minus 3k minus 3 plus 5k minus 2k squared. And what I'm going to do is I'm going to use the exact same colors and just color in what our like terms are. We have a 4k squared and a negative 2k squared. Those are like terms because they both have k's and they're both raised to the power of 2. So when I put my next line here, I would say 4k squared minus 2. Or 4k squared minus 2k squared. The next thing, because we're going to go in decreasing degrees here, I'm going to say minus 3k plus 5k, and I'm going to color it in green again. So remember guys, all I'm doing is negative 3k, positive 5k, positive 5k. Last but not least, I'm going to deal with my ones or my constants. And for people who really know their exponents, those variables with the power of 0, I'm going to say negative 1 minus 3. So now I'm just going to simplify here. 4k squared minus 2k squared, well I have 2k squareds. Negative 3k plus 5k is going to be plus 2k. Because I'm just adding the coefficients and subtracting as need be. Negative 1 minus 3 is negative 4. And that is the exact same answer as found in method 1. Let's do this one. Whew! This one looks a little tricky. So before I even start, let's just do this symbolically. We're noticing that we have 2 variables, so that's a bit more of a spicy meatball. So we have xy and xy. We have y squared, don't forget the sign in front, and we have y squared. We have the 3x squared, and we have the x. Oh, no we don't. That is not a like term. Because even though they're both just x's, this x is raised to the power of 2, while this one is not. So what I'm going to do is I'm just going to rewrite so that all the like terms are the same, or beside each other. So 4xy plus 2xy minus y squared minus 3y squared minus 3x squared minus x. And just so that we can see where all these numbers have come from, I'm just going to color the things that are the same. Next comes yellow, the y's are yellow. Oh, I never even realized that. That was not intentional. The x squareds are blue, and the just plain x is green. So now let's collect those like terms. 4xy plus 2xy is 6xy. Negative y squared minus 3y squared is negative 4y squared. These guys we can't combine. There's nothing we can do about it. I know a lot of you are thinking, we can go negative 4x squared or negative 4x. No, we cannot, because negative 3x squared and negative x are not like terms. And there you have it. And now literally step away from your question, because that's the answer. I know your guts are saying, no, there has to be a more simple answer than that. Nope. There are no like terms to combine here, so you can't. So to summarize, when we combine like terms, add or subtract the coefficients of variables with the same power.